Today, we're going to talk about nature's original high performer, a material that has been with us, really, since the dawn of our own civilization, shaping our world in ways we so often take for granted. We are talking, of course, about wood.
Think about that for a second. From the simplest shelters to the most ambitious modern structures, wood has been this constant, silent partner in human progress. It is ancient, and yet, as we're about to see, it's also startlingly futuristic.
So this brings us to the big question, right? In this age of carbon fiber and high-strength steel, where does wood actually rank? Is it this underrated powerhouse, a true renewable champion, or is it a material whose best days are long behind it? Well, let's find out.
To really answer that, we have to start at the beginning. We need to understand what wood actually is, right down to its very fibers, because its true genius lies in its elegant simplicity.
The best way to think of it is as nature's own composite material. It's got these incredibly strong, flexible cellulose fibers, kind of like nature's rebar. And they're all held together by this organic glue called lignin. Now, this structure makes it something called anisotropic. All that really means is that it's super strong along the grain, the direction the tree actually grew, but it's much easier to break against it. And, of course, the big ones, it's lightweight and it grows back.
And to get a sense of its future, you absolutely have to look at its past. You just cannot tell the story of humanity without telling the story of wood.
I mean, from the very first wooden spears our ancestors ever crafted, to the timber that framed our first homes, it was the oak in those legendary Viking longships, the massive beams holding up soaring cathedrals. Then, in the 19th century, a new technique called balloon framing completely changed the game for housing, making it possible for towns to spring up like never before. And then, much more recently, in the 1990s, an invention called cross-laminated timber, or CLT, created this kind of superply, and that set the stage for a whole new revolution.
And if you ever, for a second, doubt wood's durability, just think about this. The Horyuji Temple in Japan has been standing for over 1,300 years. It is a profound testament to just how resilient this material can be when we use it right.
So that incredible history brings us right up to today, where wood is having this amazing comeback. It's being driven by new tech and this huge global push for sustainability. Believe me, this is not your grandfather's lumber.
Just look at that number. 10 to 15%. That's the compound annual growth rate for what we call mass timber. It's not just growing, it's surging, all because we have a new understanding of what it can do.
And this isn't just about single-family homes anymore. No way. We're talking skyscrapers. The Ascent Tower in Milwaukee stands 25 stories tall, a powerful, beautiful symbol of wood's new place in our cities.
And a huge reason for this comeback is its environmental performance. This chart shows something called embodied energy. Just think of it as the total energy bill to create a material, from digging it up to getting it ready to use. And as you can see, wood's bill is just dramatically lower than concrete or steel. It's not even a close fight.
But here's the real game changer. While pretty much every other material produces carbon, wood actively stores it. For every cubic meter of wood you put in a building, you've locked away about a ton of CO2 that was pulled from the atmosphere. It literally turns our buildings into carbon sinks.
Okay, but it's not a perfect story. Wood has real inherent weaknesses, the very weaknesses that led to the rise of steel and concrete in the first place. So we have to be brutally honest about its limitations too.
So let's put it head to head. You see the advantages right away. It's low density, that excellent strength-to-weight ratio, and it's a fantastic insulator. And of course, its carbon footprint isn't just low, it's negative. But it doesn't have the raw compressive strength of concrete or the ductility you get from steel. And here are the classic drawbacks, the ones we all know about. It reacts to moisture, it can be vulnerable to rot and insects, it is of course combustible, and because it's a natural material, it has variability, things like knots and grain defects that engineers always have to account for.
So we've seen its legendary past, its incredible modern comeback, and its stubborn flaws. I think it's time to weigh all the evidence and give wood its final, official ranking. Let's break down the score. For historical impact, come on, a massive 9.5. It literally built our world. Mechanical properties, a solid 7.5. That strength to weight is fantastic, but its natural variability keeps it from scoring higher. Workability is an elite 9.5. I mean, few materials are easier to cut, shape, and join. Scalability gets an 8.5. It's renewable, sure, but sustainable forestry and supply chains are a real challenge. Versatility also earns an 8.5. It's used in everything from giant buildings to delicate furniture. And finally, lasting relevance, a very strong 9.0, because mass timber is making it more important now than ever.
And all of that brings us to a final average score of 8.8 out of 10, a truly, truly impressive performance.
That score places wood firmly in the high A tier. This is an elite material, a legend that is more relevant today than it's been in 100 years. It's not quite S tier, those natural flaws just hold it back, but it is both foundational and future-facing.
Ultimately, wood is the great comeback champion. It's a tree-powered powerhouse that has adapted and evolved to meet the challenges of our modern world, proving its value is, well, timeless.
And that leaves us with one final fascinating thought. As we try to build the sustainable world of tomorrow, you have to wonder, will the future skyscraper be forged in fire, or will it be grown from the earth itself?